This is a second lesson video for 3-3. Make sure you're at the same place in your notes. And again, make sure you pause the video anytime you're getting a little behind. If you need to hear it again, if you want to calculate something for yourself and truly make sure that you're understanding. So we looked in the last video at how to do rate of change from a graph. We counted and how to do rate of change from a table, and we'll look through that again. But word problems sometimes upset people or worry them, and in this case, there's really no need to. When they're talking rate of change and they give you information in a story or word problem, you want to treat it like you're looking for two pieces of data to make a table. So in the first problem, 1 week I worked at McDonald's and I worked for 6 hours and earned $45. Much like we've done in the past, we want to notice that they're talking about two different quantities here. They're talking about hours and they're talking about money earned. What I know is that independent variable would be the hours that I work, and the dependent variable, what changes because of that, is the money that I've earned. So in here, I'd like to look for two facts that are in that form. And in that first sentence, they gave me one. I worked for 6 hours and earned $45. In the second sentence, the next week, I worked for 8 hours and earned $60. So what I can tell from my data table then is how much my Y is changing. My salary increased $15 in the week when I increased my hours by 2. So my rate of change then would be 15, change in my Y's or my outputs, over 2 hours, change in my X's. And when I divide that out, that's going to give me 7.5, but I'm going to put the 0 there because this is in dollars per hour. And what that's letting me know is for those 2 hours that I increased from, I was making $7.50 more per hour each hour. It doesn't actually mean that I made $7.50 per hour in the first 6 hours. Maybe I got a raise, but since going from my 6 hours for $45, I went to 8 hours at $60, I made $7.50 more each hour that I worked the second week. In the second one, they want the rate of change on a graph, but they don't show the graph. So this is like a word problem. They've given us 2 data points. So I want to take those 2 data points and make a table. They didn't give them meaning, so I'm simply going to label my table X and Y. I want to be sure that I've got my negatives in here where they go. So if I were to graph these, I would be able to tell that my change in Y, which some of you were calling rise, is an increase of 10. My run, here's where you want to be careful how you're calculating this. On your calculator, it would be 3 minus -2 to see how much we increased by. Or think on a number line from -2 to 0, and 0 to 3 is a total trip in the positive direction of 5. So my rate of change then, change in Y, or change in X. And again, you can reduce this to 2 or 2 over 1. So the meaning is Y increases by 2 every time X increases by 1. So when I look at my graph, if I graph these 2 data points, I would have to rise 2 units and run 1 to the right, rise 2 units and go 1 to the right, and each time I'd still be hitting the line that that graph has. So then the question is, what's slope? And I know that last year and in previous years, they've sometimes addressed that word called slope, and we use it a lot in algebra. And I kind of wish we wouldn't, to be honest. It's the rate of change of data. The rate of change between data points. And the data points could be on a table, on a graph, those types of things. It's how they move. And it's still going to be that change in Y over that change in X. We aren't doing anything different. So anytime you see if it made sense to you, rate of change, how each value was changing, then when they say ways to find slope, you want to be thinking of ways to find rate of change. The rate lets us know that it's going to have two labels, what the y label is over what the x label is. So from a data table, let's make sure we can do this from a data table, a graph, from facts, and then by a formula. So from the data table, I can easily check what 4 minus 2 is to see that that increases by 2. And then I can check what my x's are doing. My x's happen to also be increasing. We've used a lot of positive numbers here. Just be careful. They could calculate the rise or the run to be negative. So then my slope, which is often represented in algebra by m. I always think mountains have slopes, so that maybe that's why they chose m. And my rise to run, or my change in y to my change in x, would be 2 to 5. And 2/5 is simplified, so that's my final slope value. From a graph, you still have to find your change in y and your change in x, but some of you described that to me as rise over run, because the rise tells you about what the y's do, and the run tells you about what the x's do. I would caution you, whichever two data points you pick to do this from, we've got to make sure that we've got some ideas about the positive, negative going on. So I'm going to consider that this is my starting point. To get to my next data point, I see that I'm going to have to go down and then to the right. Down means my rise number is negative. To the right means my run number is positive. If we decide those signs ahead of time, we don't have to worry so much about it. But if I start at this one, then I can see my rise is going to be negative. In other words, I'm going to have to go down in the y values. But I do get to go forwards or to the right in the x values. So I see that this is going down 1, 2, 3 units in my y's, and it's going forward 1, 2 units in my x's. So my rise to run will be -3. My run is +2, so my final slope here is -3/2. And if I look at that graph, I can see that it's losing every time we move to the right. So my slope should be negative, that rate of change. From facts, you want to see if you can come up with 2 data points. If you can come up with 2 data points, then you have choices how you do this. So it looks like they've given me a time in this word problem. And then it looks like they've given me the pool's level, the water level in the pool. The feet. And it says at 5 p.m., the water in the pool was at the 8-foot level. By 9 p.m., 4 hours later, it was at the 5-foot level. They would like to know the rate the water was draining, so they're asking us for rate of change. And I know that I'm going to make a fraction where my change in y's, and if I'm going from 8 to 5, then we have gone down 3 feet. So my change in y's is that we've lost 3 feet worth of water in the pool. But our x's, our time, is increasing by 4, and that's a 4 hours. So when I divide this out to get my rate of change, or the slope that they're talking about, I'm going to get negative, and if I divide it out, I can also leave it as a fraction, by the way, -3/4 of a foot per hour. What that's telling us is on average, that pool is losing 3/4 of a foot of water every hour that it was draining. And finally, by the formula. We'll use the formula more in the next few days, but the formula tells us how to calculate that rate of change that you've been calculating without a formula so far. It's saying you need to decide how far apart your y's are by subtracting them. Then you need to decide how far your x's are by subtracting them. And then putting that number in the numerator for the y's and that number in the denominator for the x's. What sometimes throws people is who to call y1 and who to call y2. So until people are used to it or doing that fairly well on their own, we're going to recommend that you take your ordered pairs, and the first ordered pair, its x is the first x and its y is the first y. So it gets the 1 designations. Those are not powers, those are subscripts, so they're written a little bit below the x. So that's my second x and my second y to give them names that match the formula. Then my slope's going to be my y2, which in our case is 4, minus our y1, which in our case is 6, divided by our x2, which in our case is 12, minus our x1, in our case that's 5. Once they're filled into the formula, then I'll go calculate. So my numerator is -2, my denominator is +7, and that is simplified, so that's my slope. And finally, there are four different kinds of slope that we can have. And we'll explain Mr. Slopeface here in a minute. But taking a look at what they're drawing, first they show you a line that heads uphill from left to right. And this is the one we deal with a lot. And that graph certainly looks like it's increasing from left to right. So this is going to come out as a positive slope. No matter what the numbers are, it's going to be a positive over a positive or a negative over a negative. And we're going to get a positive slope rate of change there. And on Mr. Slopeface guy, you can see him. Here's his positive eyebrow, positive slope eyebrow, and right underneath it, positive. Some people like to put Mr. Slope guy on their note card because they actually understand better that when they see those different slopes, what that means. If the line is losing height from left to right or going down from left to right, then our slopes are going to be negative when they're calculated, because one of the two values is going to be negative. We either have to come down and to the right or up and to the left. And you can see that Slopeface guy over here, his eyebrow that's got negative slope, has a negative underneath it. But there's two other kinds of slope or rate of change. Slopes or rate of change that are for horizontal lines models some data that's not changing. It's staying at a constant. So this data might be staying at a constant y value of 3. If it's a horizontal line, when I check its rate of change, it's not changing. Its rate of change is 0. Its rise is 0, but it has run. So the calculation number might be 0 over 6, 0 over 2. So if we did something with 0 slope, we would come up with 0 over any run number. 0 for rise over any run. And 0 divided by any other number is still 0. So Slopeface guy over here, his mouth has zeros on either side of it, and his horizontal lips are modeling 0 slope. And the one that I think is a little unusual for people to understand is if your line is not keeping a constant rate at all. In fact, if your line isn't even a function. If we were to calculate rise to run here, we could have any number for the rise because we can go up or down that line and have rise. But if we picked any 2 points on a vertical line, there'd be 0 for our run number. And division by 0 isn't defined in our number system. So there's two ways you can express this. You can say that the slope that we would calculate won't be defined. The other way some people describe it is that this line doesn't have a numerical slope. There is no number I can describe that slope with because there's no number that represents being divided by 0. So Slopeface guy over here has that going for him. He's got that vertical line, and then he's got the U for undefined. So finish your notes, and then you can show the teacher so that you can get the homework to work on next, or the activity that we leave.